Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Alright, so before we start doing any work with coding or using 3D models, making our characters come to life, we need of course to download the necessary tools to make all of this possible. So the first thing is, head to unity3d.com. This page is going to contain a lot of material for you, like where Unity is being used. It's used for making games and even for making movies, but also some other entertainment unrelated applications. Alright, you're going to see some details about performance, and in general it's going to show you the portfolio of Unity. It's a good thing to look at this page to see what can be done. So while you see realism here, okay, and some abstract things here, you also see some two-dimensional games, okay, some pixel art related games. So Unity is some sort of Swiss knife. You can make lots and lots of things, and it can get kind of overwhelming at sometimes because of all the necessary tools. So one of the good things about this course is I'm going to direct you to what matters into making this game come to life. Alright, so basically, just take a look around to see the portfolio. This is very good for inspiration, okay? Just by looking at the color palettes and all the models being used, this is just fantastic for you, okay? So now that we have this in mind, we need to, of course, download Unity. And to do this, you need to click here at the top right on Get Unity or Download Unity in case this page changes in the future. And the thing about Unity is, if you want to download it, you're going to be presented three different options, and these are licensing options. Okay, you have the Pro version, which has this price, and in general it's a monthly billing. You also have the Plus license, and you have the Personal one. So you can make games for free with one of the most widely used tools available. So we need to go directly to Personal, and it's perfectly suitable for us because this is for beginners, students, and hobbyists who want to explore and get started with Unity. This is fantastic. And some of the students, they commonly ask, hey, what's the difference between these licenses? What am I going to lose? I'm going to be really honest with you. If you want to make your first game, and even if you want to make several other games, going for Plus or Pro is not necessary unless you use some very specific features Unity is going to make available for you. Okay, so there are some sort of processing tools you need to use, some lighting tools, and they're very useful for making things really realistic and also optimizing games, which is, you know, a fantastic thing to do. Sometimes it's even required. But since this is your first game, you're giving your first steps into making this game, Personal is going to work well. There are some revenue restrictions, like you can't make more than 100K American dollars a year. Okay, so if you're not inside, if you are inside that restriction, then it's just fine for you. All right, so you're just going to see here Personal free. That's perfect. We're just going to click on Try Personal, and remember to read the terms of service. Take a look on all of these requirements that you have here. So if you are eligible to use Unity Personal, just accept the terms and click Download Installer. Okay, in my case I'm going to download this for Mac, but if you are on Windows, it's going to show something like Download Installer for Windows. Okay, and once you click there, it's just going to download an installer for you, right? So I'm going to open my Downloads folder here. You're going to see this Unity Download Assistant. And if you open it, it's going to mount in the Mac, or it's just going to open the installer on Windows. And once that is done, let's just open the app. All right, I'm going to show you something really important here. So when you open the Download Assistant, Unity is going to kind of verify online what is the latest version of Unity available. So just a little introduction here. Okay, we're just going to continue. Agree with the license, as I told you before, if of course you agree. And then Unity is going to show a component selection. And this is really important here because if you do something wrong here, you might need to re-download everything again. So I'm going to explain what's necessary here. First of all, of course, do not unmark this one. This is basically Unity. Okay, it's the actual game development tool we're going to use to make our games. And that's Unity 2010.2.5. In this case. You might have a different version if you watch this course in the future, but the fundamentals are going to be essentially the same. There might be minor changes, but to be honest, they are not very necessary. If anything happens in the future that needs some sort of patch in this course, don't worry, that's going to be covered. We also need to mark Visual Studio for Mac or for Windows or for whatever platform you use, because this is the scripting IDE. Okay, this is the tool that's going to help us code everything we want to do in our project. So this started unmarked in my component selection because I already have Visual Studio. But if you don't have, make sure you have this selected. This is really important. Okay, so documentation, really important to have. It's something good to have. But if you don't have documentation, you can always check it online. Okay, and besides these three first options, I highly recommend three other options: Android build support, iOS build support, and WebGL build support. The first two, because these are the most widely used mobile operating systems. So if you want to later port your game to smartphones or make games in smartphones, you can always use these two here. Okay, and the last one is if you want to make your game available on the web using WebGL. Okay, so it's going to be very easy for friends, family, or customers to just play your game by just opening a web page. All right, once you're done with this, you're just going to click Continue. Alright, check the component licenses to see if everything is fine, and just select where you're going to download Unity. Okay, in the destination select. And I'm going to stop here, okay, because I already have Unity installed. But in the meantime, while Unity is installing, it might take a little while to download. Make sure you create an Unity account, okay, in the same page, in unity3d.com. Make sure you create your account there, put your credentials, put a valid email, because you might be required to log in once you open Unity for the first time. All right? And also remember, make sure you check the Unity page, see all the things that's going to get you pumped up to start this course. All right? So once it's complete, let's move forward to the next video. Alright, so if you have reached this point in the course, then congratulations. You're just a few steps away into starting this amazing experience in making a battle royale game. Alright, I'm going to be a great mentor for you. We're going to check things one by one, okay, one step at a time in a nice and steady pace, so we make all of this possible. Right? So the first thing is, when you open Unity, it's going to maybe show a few tutorial pages for you to click, but you don't need to check that right now because, of course, we are in our own fantastic tutorial. And the first thing we want to do is to create a new project, because every game you make is considered a different project. It's like it's a different folder in your computer that's going to contain all of the necessary files for your game. Okay? So we're going to click here in New Project, or it might be a button in your interface, and we need to give a project name, which I'm just going to name Battle. Notice that this name is not going to be something, eternal. It's not going to be Battle in the App Stores. Later, you can choose another name for your game. So just want to give a generic name, or you can give your own name. It's like an internal coding name. Okay, so we start with Battle. The location, I'm going to choose this. Since I'm on a Mac OS, it's going to be users / my username / projects. Maybe you don't have a projects folder in your computer, but I highly recommend you to create this, because it's really common to have multiple projects in different folders, like in the desktop, in the documents folder. So it might get messy sometimes. You may want to find your projects which much more speed, but that might not be possible because you don't have a projects folder with all your code, with all your game assets. So we make sure we make a projects folder here. And whenever we make a new project, Unity is going to automatically create a folder for this project, which I'm going to show you later. Okay, so I'm going to use user/my_username/projects, and it's going to make a battle folder there. Okay, template is going to be 3D. There's no need to enable Unity Analytics for this project. You might want to enable that if you want. And I'm going to show you how quickly you can make something work in Unity. Okay, we're going to click on Add. Actually, we're not going to click on this one at this point. Okay, I'm going to show you soon. So once we have all of these settings here, everything in place, let's click Create Project and just wait for a little bit. All right. So Unity is actually dealing with hundreds and maybe thousands of different files right now. For building the default project, okay, it's going to basically build the starting point for us to make our game. So you just have to sit a little bit, and it's going to, we're going to start, right? And before we delve into explaining Unity, into all of its details and explaining code, we want to get our hands dirty. That's the first video. That's the first time you're opening Unity, and maybe you just want to check something working, okay? And that's going to be quite simple, as I'm going to show you right now. Right? So Unity opened. No need to get any details right now. We're just going to wait for everything to load. So we're going to click here in Assets, Import Package, and we're going to choose Characters. All right. After clicking Characters, just hit Import. There's no need to check or uncheck any of the boxes that appeared there. All right. Just a few seconds, and a new folder is going to appear here in Unity. All right, but again, no need to understand any details at this point. All right, just sit back, relax, take a look at the interface, get familiarized with the buttons, with where the windows are, because even though you don't know what they mean at this point, we're going to understand more about them soon enough. All right. So, and that's going to be precisely in the next video, where we're going to cover all of the Unity interface. So what's hierarchy, what's the game window, what's the project folder, how to organize things. And not only you're going to learn what these things are, you're also going to have some tips from me. All right? So good, a new folder appeared here, which is Standard Assets. Fine. We go again into Assets, Import Package, and now we're going to choose Prototyping. All right? Select that button. Same folder is going to appear here. Just hit Import. All right, it's going to, one more time, get some files from your computer, copy and paste them into your project, and it's much faster. All right? So this is what I want you to do. Go to the Standard Assets folder, then Characters, Third Person, Prefabs, and you're going to see this Third Person Controller prefab. Okay, it's this little blue cube. We're going to drag this and drop here in the hierarchy window. Okay, just do that. No question asked at this point. All right. Now we go to Standard Assets. We go to Prototyping, Prefabs, and let's see which one is going to be better here. Okay, let's choose this one. Floor Prototype 64 by 1 by 64. All right. Just drag this from this position here. All right. Again, no questions asked. Once that is complete, we're going to hit the play button. Okay, something really quick. There is no need to find any details right now. And you're going to see that your character is moving. All right. If you want to see things in full screen, you can even click here and hit Maximize. Okay. And now we already have a player here. And if you actually hit the WASD keys or the arrow keys, that character is going to move. All right, and that's perfect. That's exactly what we wanted to happen. With just a few clicks, with just a little dragging and dropping here and there, we already have a moving character. That character can also jump. That character can walk around if you hold down the Shift key, and it's essentially going to work. So that's going to happen a lot in Unity. If you have something that can already be reused, we are going to use that. It's very common to see some developers that are, I don't know, maybe too proud with using all of these elements, all of the things that compact in Unity, and they want to do things by themselves from the ground up, but that's not productive. Okay, you're going to lose time. It's not going to be necessary. It's already done for you. So if you use these things, if you use these tools that are already available for you, you can speed up your project development by a lot, okay? And get to the real deal, get to making your games, all right? So now that we have this done, we're going to finish this video and move on to the next one, where I'm going to show you what all of these buttons and all of these windows mean in Unity, okay? So I hope you're excited that you saw all of this, and I see you in the next. Okay, so now that we have started, there's just too much to see in this screen, okay, like we saw in the previous video. There are lots of windows, lots of buttons here and there, and I know how you might be feeling if that's your first time making a game. It's just too much. I can't learn this. It feels like it's going to take forever for us to use all of this, but it's actually quite simple. Because if we look at things in a practical way, in doing things step by step, it's just going to make complete sense. Okay, so the first thing I want to talk to you is about the game window. Okay, so that's pretty, it's kind of the easiest to explain right now. The game window is, as the name suggests, how your game is looking like. So what you see here, it's going to be a precise simulation of what your players are going to see when they play your game. Whether it's in a Mac, in a Windows computer, or in an Xbox, okay, in a mobile phone, it doesn't matter. This is how the game in general is going to look like. And if you press the play button, you're going to see the simulation running. Okay, so the game is going to look like this, period. Okay, nothing else to talk about this. Just hit the play button and you can play this game as they were playing in their own app. Okay? If you pause, of course, the game is going to pause execution, and if you hit this button, you're going to make your character kind of simulated frame by frame, so you can see animations in detail to see if things are working properly. But in general, you just have to hit play to start and hit play again to stop the simulation. Right? That is the game window. This is what players see. Whenever we talk about the game window, we also talk about the scene window. Okay? And when you are here, it seems like it's the same but from a different angle. Okay, I can see the floor I added, I can see the player, the skybox, and I can do pretty much the same thing in the scene window. But the game window is made for players, and the scene window is made for developers, which is me and you. We are building this game to make it fun, to make it enjoyable, to make it nice, and the scene window is our exclusive view of how the game is looking like. And you can see other things here that you don't see in the game window. For instance, you can see this little icon here that is the camera icon. You can see the player, you can see the floor, and also if you right click, you're going to see that your mouse turns into an eye icon. You can now look around this entire scene in a free look. Okay, so that's pretty nice of us to have, so we can see things in detail. Right? Look at the camera, we can look at the sky, we can see the sun there, we can see this other icon. And another really useful thing to have is if you right click and you press movement keys like the arrow keys or W, A, S, and D, keys normally used for shooter games, you can move your camera. Okay, so W, S, A, and D. You can also use Q to move down and E to move up if you want. So this is going to be really, really useful, and especially whenever you're making a three-dimensional game like this one. Okay, so I highly suggest you to just pause the video right now, okay, and take your time in the scene window. Just right-click, move around a little bit, all right, just check things, maybe zoom out enough so you can see the entire floor and zoom in really, really close to the player's face, for example, just to practice a little bit. This is really useful in three-dimensional games. So just pause the video right now and try a little bit. All right. So if you're done with that, well, that's pretty much what you have to look at the scene window. Here at the top right, there are a few other buttons you can press to help you align things like game elements. So if I press here, this red knob, okay, it's saying X, is going to show things from the right. Okay, Z front, This one is left, back. Okay, if you click here, you're doing some sort of quick rotations here, quick camera arrangements like this. If you click on top, it's going to look from the top, right? And you can also click here to move to the bottom. All right, so you can just play a little bit with these buttons to see how they change the orientation of the game. But you also see here perspective. If you click, it goes to isometric mode. This is going to be how the game would look like if it was two-dimensional. But we're not going to use this ISO mode here. We're going to use perspective because this is a three-dimensional simulation. All right. There are other buttons that you can use. This one can enable or disable lighting. Okay. At some points it might be useful for not making your game take lots of resources in this window. Okay, it's going to be kind of much quicker to execute if you compare with the game window. Okay, there might be a little bit of a stuttering here since I'm recording and playing the game, but you can see that the scene window is much faster because we disabled lighting. Okay, but you can of course enable it if you want. I'm going to leave it enabled at some point. We're going to evaluate that as we move through this course. Okay, so that's pretty much what you have to know about the scene window and the game window. Okay, these are the simulations of the game. The game for the player, the scene for the developer, which is me and you. So in the next video, we're going to go over other elements that are not visual. The other windows we have in Unity at this point, they are not as nice as the scene or the game windows because you can see beautiful things, okay, like the 3D player and the floor. They might seem boring at some point, but it's going to be so important for you to learn about this. And if you learn them well, it's going to be so useful for you in your game development skills in your career. I mean, you might not have an idea about this, but it's really important to understand these things well. Okay, remember, whenever we are learning or working with technology, things are going to change in the future. This is guaranteed. 6 months from now, we might have a new technology, a new game engine. It might be much better or not, or maybe it's just an alternative that you can use. But if you learn the basics of organizing things, okay, about I'm not talking about learning how to use the best graphics or using the best 3D models. I'm talking about technique in organizing things. Okay, if you do these basic things well, you can learn really quickly whatever you want. Okay, so it's really important to understand these concepts. And the first one, which is a concept that exists for a long time, okay, ever since we had the first games, is hierarchy. And Unity has a window just for that. Okay, the first element in the hierarchy you see here is sample scene. Okay, and the scene is, as the name suggests, the place where you're going to put things, and that things could be lights, it could be the player, it could be vehicles, weapons, it could be whatever is going to be inside your game. This is like a list view, a tree view in that case, of whatever you see in the scene window and the game window. So I can see there is a player here, there is a floor, there's the camera, and there's the sun here, the light. Okay, and if you look at the hierarchy, that's what you have. You have an object called main camera, which is this one. You have another one, which is the directional light, okay, which shades the entire screen, okay, adds some light. You have an object called third-person controller, and you can see that as I click on these objects, they are highlighted here. And we have another one called floor, okay, and if you click, it is highlighted, okay, it is outlined in orange, okay, so we see every element inside the scene here. You notice that I'm not just calling these four elements things, okay? I'm not calling them stuff. They are objects. And to be more specific, they are game objects, okay? It's a name used in Unity for a lot. The game object is the basic building block for making your games. Everything is a game object, okay? From things that you can see, like the light or the sun, to things that you can see, like the player. Okay, like this one, like the third-person controller, right? And another important thing to note, we have the sample scene here, and we have this arrow to the left of sample scene. If you click here, it's going to collapse whatever is under the sample scene. If you click again, it's going to show things. Okay, so you can hide and show elements. This is showing exactly what the name suggests. This is a hierarchy. These 4 game objects, they belong to the sample scene. I'm going to use that word a lot, belong, or they are under the sample scene. They are inside the sample scene because they belong here. Okay, so the main camera belongs to the scene, directional light to the scene, the player, and the floor. Okay, and if you look at the player, you also have an arrow here. You can click here, and it's going to show 3 different elements. And we have the same thing here. We have Ethan body, Ethan glasses, and Ethan skeleton. And notice that a few of these elements can be selected. So these 3 elements, they belong, they are inside the game object named third person controller. So what happens is when the third person controller moves, everything inside it is going to move as well. Okay, because these 3 elements belong to the third person controller. Okay, so for instance, if you press play here and you look at the scene, if you click on the glasses, you're going to see the glass highlighted here. So the player is animating, it's looking around, okay, just switching, just moving a little bit to the left and to the right, and you can see that the glasses are moving along with the third person controller. Okay, so that would be really hard and really messy code-wise if there was not this hierarchy. So it is important that whenever you are doing something for the first time, or even if you have years of experience in game development, for you to plan ahead whatever you're going to do. So I'm going to make a ship. Okay, that ship is going to contain an object just for the thrusters, another one just for the cockpit that might open or close, another one for particle effects. Okay, so these, if you think about the work necessary to make these work, these are the easiest things to do. It's just 2 clicks away from making them appear in your scene. But if you don't do this right, it's going to turn your game into a train wreck in the future. Okay, so make sure everything is organized, all right? And along with the hierarchy window, notice that whenever I select a game object, not only it is highlighted here in the scene window, you also see that in the inspector window, things are going to just appear here. Okay, so if I click in the main camera, stuff is going to appear here. The light, another thing is going to appear here. Okay, these objects, okay, whatever you click, in the inspector window, this is going to show information about that game object. And that is also vital for you to tune your game to whatever experience you want. So for instance, if I select the main camera here, it's going to be loaded here. This first rectangle is kind of the information about the game object. The name of the game object, in this case it's main camera. You also have a tag and a layer. There's no need to see these things right now. Okay? And below this rectangle, you're going to have kind of 3 different folders, 3 different components here. And that name is going to be key here. These are components. They are elements that change how your game object is going to behave or how it's going to look like, for example. Okay, you can even collapse these things and see them as a list like this. Okay, if you choose the player, for example, you're going to see there are a lot more components. It's a lot more complex. But again, these things are going to make sense as we move forward in the course. Okay? So for the camera, for example, we have a compiled card transform. And there are 3 lines here: position, rotation, and scale. So for this one, I'm going to the game window. Okay? And here in main camera, if you change the position of in X, instead of 0 to 1 or to 2, it seems like the player is moving. Okay, so you might be thinking, hey, why the player is moving? That's not actually the case. What is moving is the camera. And for you to easily visualize this, you could click here in the X label and just drag your mouse around. Okay, because of how the floor has been set, you might have that illusion that the player was moving, but no. What is moving is the camera. So this is interesting for you to fine-tune positions. Just click in a label, X, Y, or Z, and just move your mouse around. Okay, however, and as much as you want. Okay, I can put X here, I can do the same thing on Y to move the camera and on Z as well. And notice something interesting. These three things, they behave differently. X is the horizontal position of the camera. Y is the vertical one, so how high or how low the camera is going to be. And Z is the depth axis. Okay, so it's how close or how far it's going to be. And that's the basics of 3 dimensions. You have 3 different dimensions, X, Y, and Z. Horizontal, vertical, and the depth axis. Okay, and these things are going to basically be used at all times. And dealing with these numbers needs to be really, really natural for you. Okay, we're always going to work with these elements, right? We also have rotation. We can rotate in the horizontal axis, like this. Okay. We can rotate in the vertical axis. Okay, it's kind of like we rotate as human beings. And in the z-axis as well. It's going to tilt to the sides. The best way for you to look at these things is going to the scene window and getting close to the camera. Okay, changing the position on X, position on Y, and position on Z. Alright, same thing about rotation. X, Y, and Z. This is really, really important for you to get right. Okay, if you, I mean, anybody can code, anybody can make a game, and the basics are the most important thing. Right? Position, it might seem boring, it might seem pointless at first time, but this is going to be essential for you. And if you want to move the camera, you can also click on these axes here. Okay, this one, or even this one for depth. But you can also click on these cubes to move 2 axes at the same time. Okay, like this or like this. You can do a lot of things in the editor. All right, and we also have the scale line. If you go to the player, for example, if you select third-person controller and you change the scale on Y instead of 1 to 2, notice how fun it's going to look like. The player is much taller. Okay, you can do the same thing on X here and on Z. Okay, so you make the player taller. You can make it fatter or thinner. Just a few clicks away and you're going to achieve these effects. But we're going to stand on 1, 1, 1, okay, which is the default value. Notice that 0, 0, 0 on the position is the default position, the origin. 0, 0, 0 is the default rotation, but the scale is 1, 1, 1. 1, you should think about 100%. It's like full, okay? This is how it should look like. Alright, so back to the game objects. We're going to select the directional light at this point because we're going to look at other things. In the camera, we have the transform component, so we dealt with that a little bit. But for the light, for example, we have the light component. And there's that little checkbox. If you disable, the scene is going to be fully dark. Okay, there's no more light, just a little bit more. It's not necessary for you to understand why there's a little bit more light, but still, it's really, really dark. Okay, if you look at the game window, you can just see the sunset here, but we're going to enable it. And a few things about light is, there are lots of different properties, lots of different fields that you can play with, just like with the camera, right? For example, color. If you want to change the color of the light, you can just click here, and instead of that yellow look, you can choose, maybe if you are at Mars, for example, you can choose a strong red or orange light, and it's going to give a complete different look for your game. Okay, you can change it to blue if you are underwater, for example. You can do lots of different things, achieve lots of different effects. It's just a matter of you deciding how your game should look like. Okay? There are other properties here like the intensity of the light, how strong it's going to be, how the shadows are going to look like, right? Flares, if you look directly at the light, if there's going to be that sun effect. So there's a lot of things that you can deal with here. And the same thing with the camera, right? If you choose the camera, for example, and you go to the game window, you can change the field of view. Okay, you can make it large like this, so you see a lot. You can make it really small, so you see like the camera is zooming in at something. Okay, but we keep 60 by default. Right? So another thing, another really important thing, you have to be curious about the games you are making. Okay, even though I'm going to tell you, hey, do this, hey, do that. it is really important that you are curious enough to just try and change a few of these values, a few of these numbers. Playing with the interface is essential for you to learn everything Unity has to offer, and to be honest, whatever programming language you use has to offer. Okay, try changing things, change colors, really break whatever you're doing, because when you, if you check all the values, if you fix whatever you're doing, it's just going to mean a lot for you. Okay, so we looked at game objects, we look at the inspector, and now we need to look at the rest of the interface. We're going to look at this in the next video. Now that we have looked how game objects work, so where they are listed in the hierarchy, how do they look at in the inspector, we want to look at the remaining windows here at the bottom of the Unity editor. So we have two windows to look at. We're going to start with Project. The Project window is going to contain all of the folders and files necessary for your game to come to life. So here we're going to have scenes, like the one you see right now. We might have scripts, we might have prefabs, we might have 3D models, background music, sound effects, everything that belongs to your game needs to be in this folder. So in most games you make, it's not going to be necessary for accessing files that are outside the assets folder. Okay? If you right click here in assets and you choose a reveal in Finder or in Explorer if you're on Windows, you're going straight to the folder where your game is. Okay, so it's basically in my home folder /projects and then /battle. Okay, so your game is going to be everything inside the battle folder, and more specifically inside the assets folder like you see right now. Okay, so we have scenes folder, which has this sample scene here, and we have standard assets, and you saw the standard assets before. Here in the characters folder you have 3 other folders of other elements that you can use in your game, files and all of the other things. And we also have a console window. This is going to be essential for us in building a game, especially when we are making scripts. This is going to show us debug information about whatever we are making. So if there is an error in our code, or if there is a warning in how the game is behaving, it's going to appear here. And we already have one warning here. It's saying, hey, no main camera found. Third-person character needs a camera tagged main camera for camera relative controls. Okay, and that's fine. What we have to do here is we go to main camera, we select the tag here and change from untagged to main camera. Now the next time you execute your game, if you press the play button here, that warning is going to disappear because this component here, which was created by Unity, this game object, it's going to behave as it was supposed to behave. Okay, so if you get the camera here and rotate to another place, for example, like this one, it's going to work well. Okay, so we can stop the scene, and that's pretty much it. Okay, whenever we make a script and we go to the console, errors might appear here, or maybe we as developers might add some information that we want to check in the console. Okay, and that's going to be pretty much okay. Alright, so that's everything you need to know about the Unity interface for now. There are new things that we're going to learn as we make the game, okay, but these are the basics. Right now, we just want to save the scene with everything we did here, which was adding these elements, moving the camera around, and finishing this startup point. So now we're going to File, Save Scene, and notice that before you save, there was an asterisk here, and that's a kind of a hint Unity is giving you. It's telling, hey, you modified this scene, remember to save it before you leave Unity or close your computer. Alright? And if you want, you can also rename the scene. Okay, just go to Assets folder, Scenes folder, select the scene, right click, then we're going to rename it to Game. Okay, and it automatically updates here as well. We're going to start with a very simple and straightforward name like Game. Okay, so now that we're done with this, we're going to save everything and move on to the next video. Alright, so now that we know everything we need to know about the Unity interface at this point, we're going to learn about scripting, or coding, or programming. And that word makes some people have some chills. They are scared about learning how to program because It's something that's difficult to understand, and all of these binary numbers and all of these complex concepts. But again, that fear is just holding you back from learning how to code. Okay, and that's really important because that's the most important tool for making whatever you want in the computer, whether you are a game developer or just any other type of developer, okay, any other type of programmer. Scripting is going to enable you to communicate with your game and tell it exactly what it has to do. So, what the player is going to do if I press the space bar, what the camera is going to do if I click with the mouse button, with the left mouse button, the right mouse button. How difficult is the enemy going to look like? How can I connect with my friends and play online with them so we can battle together? So all of these things, all of these questions, they can be answered by coding, okay? And there are other tools you can use to allow you to make an entire game without coding, and that's great as an introduction. But as you move forward, you're going to see that these tools that don't enable you to script, or they enable you to script in a limited way, they're not going to be enough for you to make everything you want to do, okay? Maybe you want more beautiful visual effects, maybe you want more complex controls, you want to make a game that can be played by 30 different people. So there's a lot you can do, and learning how to code it just completely opens possibilities. Okay, you're going to be able to pretty much do anything you want with any tool you want. Again, it's the importance of making you future-proof. If you know the basics, if you know the concepts, it doesn't matter what happens in the next 6 months to 5 years, you're going to relearn things in a much faster pace. And that's why we want to learn how to code, all right? The first thing we want to do is to organize our assets folder a little bit. Notice that we have two different folders right now. We have scenes and we have standard assets. So the standard assets folder appeared in this place here. And standard assets, we never did anything, we never created any of these assets. I mean, we didn't make this player or made this script that makes the player move. So that's a third-party asset. And because of that, there might be a problem if you later use Unity's asset store to download, for example, a pack of skyboxes or an interesting robot, for example. The folders might get mixed up here. So the first thing I tell my students to do is to go to the assets folder, right-click anywhere here, choose create, and then folder, and name this folder project. Some of them might think, hey, that's redundant. There is no need to add a project folder. But as I told you, it's going to prevent some sort of conflict with folders or just making things messy, okay? Let's make things organized. I'm going to move the scenes folder inside the project folder. Okay, so it's going to look like this. And inside this folder, you can pretty much do whatever you want, okay? And being, safe about all of these operations. So here in the project folder, we right-click, choose create, and we're going to choose folder. And I'm going to rename this folder to scripts. That's simple. And now inside the scripts folder, we can do whatever script we want to work with, okay? And in this situation here in the hierarchy, we're going to make a script just for the player, okay? We're going to do some very simple testing. So in the scripts folder, we right-click, choose create, and then C# script. Once you click here, Unity is going to prompt you to select a name, and I'm just going to name this player. We could name this hero, we could give it a name like Bob, or using Ethan, for example, as the name suggests. But remember, the simple solution is always the best one. So instead of giving specific names like player or male fighter or female rocketeer launcher, for example, all of these names, instead of that, just use the name player or enemy, obstacle, weapon. The more generic you are about these names, the more you're going to kind of prompt yourself into thinking how the scripts should work, how the hierarchy should work. You're going to understand that again once we move forward. So now that we made this script, we want to write some lines or maybe edit it. So I'm just going to double click the player script. And once I do this, you see Visual Studio is going to open. And as I told you before, if you selected Visual Studio, it should be installed in your computer, and it's just essentially going to open. It might take a while because that's a more complete IDE, okay, a more complete solution for writing some code, but it's worth it. You know, just wait for a few seconds and it's going to open like this. All right, I'm going to zoom a little bit, like you see here, so you can see better, but you can use whatever setting you want. And also, you can use whatever text editing tool that you want. It doesn't have to be Visual Studio. You could use Sublime Text, you could use Mono, which was discontinued, but again, you can always find your way into using these tools. But to be honest, use whatever is packed with Unity, which in this case is Visual Studio Community 2017, or whatever version you get to see. Okay, and now that we have this script open, we're going to spend some time understanding what all of these lines mean. Okay, again, don't be scared about these things. You know, all of them make sense. It's just a matter of you to learn these things, use them for the first time, and you're going to see exactly what they mean. Okay, so let's work on this in the next video. Alright, so let's take a look on what we have here. You notice that the first 3 lines in this file start with using, okay? And these using lines, they are kind of related to what I told you before. You don't have to make things from scratch if there's something available, okay? You don't need to reinvent the wheel. If it's available, if it exists, you're free to use. And the using directive, this word here means it's going to grab code from somewhere else, right? It already comes with these 3 lines because they are very useful into making the remaining ones work, okay? The first 2 are essentially importing or using code that is, you know, used for collections, okay? Like putting many things together. In the 3rd line, using Unity Engine, it essentially means, hey, we want this script to work with whatever Unity has available to offer, okay? The basics of the Unity engine. So all of these are necessary for all of this to work, okay? So essentially, using is going to grab code from somewhere else and make your script be bundled with several different functionalities, okay? And now for the most important part of this script at this point. This thing here, public class player, this colon mono behavior, and then whatever is between curly braces. So public means that whatever you put inside here is going to be visible to other scripts, okay? So if it was private, nobody else outside of this file here would be able to find the player. But since we're going to work with the player a lot, we just leave this public, okay? And the class is essentially going to give you a list of behaviors and a list of fields that can be used around. So a class is going to contain variables, okay, like the player's health or the player's ammunition, okay. It's going to have methods for making functionalities work, like jump or crouch or lay down on the floor, okay. And player is the name that we gave for this script, which is the exact name of the class, okay. The class is kind of the generic representation of the player. You will have a class for the player, you have a class for weapons, for bullets, you know, for many different things. Okay, so the class is going to do that for you. And what does the colon mean in this situation? This is specific for C# and other languages. Whenever you see the colon, you need to think, hey, the player extends a mono behavior. And what does that mean? That means that whatever the mono behavior does, player is going to do as well, plus whatever we define inside the player. Okay, so what does that mean? Mono behavior is going to contain some generic behavior for any Unity game object, okay, like accessing the player's position, the player's rotation, the player's scale, all right, and changing these properties, accessing other components. It might seem a bit blurry right now, and that's completely fine, okay, because that might be the first time you're looking at this. But just think about this like this, okay? We created a player, and that player is going to contain all of the behaviors that the class mono behaviors implement, okay, the base class. And in this file, we're going to use whatever useful scripts we have from these three namespaces: Unity Engine, System Collections, and System Collections Generic. Okay, and inside curly braces, I'm going to do things. I'm going to define things that belong to the player and not to mono behavior. We are extending mono behavior and making our own player. And I mean, the more you work with this, the more automatic the process of making scripts is going to be. Okay, so while you're looking at every word you see here, at every element you see here, okay, take some time. In the future, you're not going to even see these words, to be honest. It's going to be automatic. You're going to kind of visualize what this code is. Okay, you're going to look at this and you're going to think player. Look at this and think update. Look at this, think start. Okay, the characters are important, of course, but don't worry, it's going to be natural for you in the future, right? So we have the player. We know using, we know class. And what are these things? Okay, these things are methods. And in a way to sum it up, a method is going to be an operation which is going to be executed. Okay, so for instance, if you are, let's say, if you're watching Netflix, for example, and you want to, you grab your control or you grab your gamepad if you're watching on an Xbox, and you press confirm to watch a movie. Okay, the act of confirming, it's kind of saying, hey, Netflix, I want to watch that movie. So inside the code of Netflix, you're calling something like play movie or select movie. Okay, it's an action, and that action is going to have a reaction, right? When you tell your television or your app that you want to watch something, that app is going to say, hey, okay, I'm going to play that for you, and then it's going to play. Okay, the word is this: it's action, it's doing, it's an operation, a set of instructions that you want your game or your app to execute whenever these are called. And what Unity does for us in this situation is to make every script you create already contain two methods: start and update. And these are really important, and that's not only for Unity or C#, that's for game development in general. Okay, and there is already a comment here which I'm going to explain soon. Okay, the start method, Unity is going to automatically call this method whenever this player is ready to be used. Okay, so what does that mean? Whenever you start your game, that game is going to load. Okay, you might remember that from these boring loading screens we see in every game. Okay, because it's a complex process. It's going to load multiple files, and it's going to load audio. It's going to load background music, animations. It's going to download information from the internet. So that's a lot. Okay. And the game elements, they can't do anything until all of the resources they use are available. Okay, so for instance, the player can't begin to exist until we have this 3D model loaded into the computer memory. I mean, this is highly detailed. Okay, so we can't use it if that's not complete. All right, and the animations of the player are not complete. We can't do anything. But whenever we have a green light that's going to say, hey, the player is ready, you're free to use it, the start method is going to be automatically called here. You don't have to call this method, okay? It's going to be automatically called by Unity. In the future, we are going to make our own methods, but everything you need to know right now is that this is going to be automatically called. So whatever you put between these curly braces is going to be executed, okay? And let's look at more detail what this method structure looks like. What you see here is start. This is the name of the method. Okay. Internally, your computer is going to convert that into a really unreadable format. Okay. But since we are coding, we want to use a human readable language. We need to make our lives easy. Okay. It's very common for some programmers to not think a lot about the name they're giving to their methods or to their variables. But this is really important. Okay. Because coding, even though it's complex when you make a huge game, okay, it still has to be simple if you read the name of methods and variables. It needs to make sense, so it's going to be natural for you to, hey, there's a bug on a certain thing. If the code is organized, you know exactly what class you have to look at, what method you have to look at. So making things organized from the beginning is very important. And so we have a name, start. Whenever the player should start existing, should start working, we're going to do whatever is here. What does void mean? Okay, the text that comes before the name of the method is the return type of that method. And what does return type mean? So for example, a very common mathematical operation is an addition. You get two numbers, you're going to add them, and you're going to get a result. So if you want to use 2 plus 3, the result of this is going to be 5. So result is the keyword here, okay? It's going to be the return of your method. So imagine there's a method called add, okay? So let's do an example here. There's a method called add. It's going to have two parameters, 2 and 3. And if you put these two together, the return of that operation would be 5, okay? And the return type of that is going to be an integer. It's a number, okay? We're going to go into that really soon. But again, the start method doesn't need to return anything. It doesn't need to inform anything back to us, the developers. It just needs to execute whatever is listed here. So we have the return type void, which means don't return anything. There's nothing to be seen here. Just call the method, do whatever you have to do, and move on to the next instruction. Okay? Between the parentheses, you can pass a set of parameters. Okay? So the start method doesn't have any parameters, but if you make a method like add or subtract, for example, all of these, they need to have parameters because you're adding a certain amount of numbers. Okay, so let's say number 1, number 2, subtract number 1, number 2, and so on. All of these things, they might require parameters, and the parameters are informed between the parentheses. Okay, and after the parentheses, you have to open and close curly braces. This is the scope of this method. Whatever is inside here belongs to this start method. Okay, that's pretty much what you have to do about what you have to know about the method structure. Right? This is the start. This line here is essentially a comment. Okay. Of course, we're going to write instructions. We're going to call methods, work with variables all the time. However, it is important for you to comment your code. This is really important because if you look at your code, it might not be that easy to understand something. Sometimes you have to implement a complex algorithm, algorithms that work with network connections, or just do a very complicated operation. It's hard for us to understand by reading these lines. I mean, it's hard for you that made the algorithm to understand that. So whenever you use comments, you're using human language. It's like you're talking to somebody to explain something. And it's essentially what's doing here. It's explaining what the start method is for. It just says, use this for initialization. Okay? This line is not going to be inside your game whenever it's bundled into a file. It's just used for development, but it's one of the most important things. You need to explain to help yourself understand what's happening and to help your fellow teammates that are going to code this game with you. Okay, so making this, documenting your code, explaining what's going on is really important later for maintenance and even whenever you are developing this. Okay, we also have a method called update. That's going to be a little bit harder to understand, but this is how it works. Okay, so whenever you're playing a game, you just see very fluid movement. Okay, let's hit play here again. Right? I'm going to hit play. I'm going to get the player close to the camera. So movement is really fluid. Okay, you can see the player walks around. It looks like a human being. This is something we believe in. Okay, this player is here. It exists. It's going to move around. That's fine. But okay, if you look under the hood, if you press this key here for jumping frames, video, okay, that notion of movement is just a bundle of pictures being switched really fast. So if you just click on this forward button here instead of the play button, you can see things working frame by frame, picture by picture. And Essentially what a game is going to do is to build a huge amount of pictures in very high detail with high complexity, putting them together, playing at a certain speed, and it's going to look like this. Okay, it's going to look like something really beautiful and really fast. Okay, but again, this is just a bunch of pictures being rendered, being drawn by your game, and these are called frames. Okay, all of these little pictures that are bursted all one after the other are called frames, and the update method here is called once per frame. All right, so whenever a frame is created and drawn on the screen, it's going to call the update method. So at first you might think, hey, what is the update method required for? This is one of the most important things, because when you look at the update method, think of it as something that is being called all the time. Every frame possible in a game is going to call the update method. The update method of the player, of the camera, of the light. Okay, every code that needs to be executed in general happens in the update method. We are of course going to make our own methods to do other behaviors, but if you want to do something that needs to be verified at all times, like if a key is being pressed, the update method is the one you want to worry about. Okay, so this is essentially what we have to learn about this script. Okay, using directives, the player, these two methods here. And even though we spent some time here, we talked a lot about the importance of making things organized. This is going to be really important for you for making this game and making a good career. All right? So now that we learned about these things, we're going to move into the next video where we're going to call a method and see what's going to happen. What we saw in the last video was everything that is pretty much written in this script. We talked about creating methods. Okay, we have void start, void update, and I did a whole explanation on what methods are. But how do we execute a method? How do we call a method? We want to do a very quick example here. Okay, so you might have seen from other programming tutorials that the beginning of your entire journey as a coder is writing a hello world program. Okay, and how exactly are you supposed to do that in Unity with C#? Okay, with this programming language, we are going to the start method, and we want to print the message hello world. Okay, so let's write hello world like this first of all. Okay, you're going to see this red line here near the word because the code is wrong at this point. Okay, it's not exactly correctly written, but we're going to do that soon. Okay, so hello world is a string. This is a text because it's enclosed by these two double quotes. All right, so this is the message we want to print. So to call a method, we want to call the instruction we want to execute is called log. Okay, it's just these three letters. But if you just type log, it's not going to work because this script doesn't know where to search for log. Because of this, we're going to type debug. And once you type debug, you can see here in this intelligent box that you're accessing a class called debug. And there's even a little explanation about it if you install the documentation. It's a class containing methods to ease debugging while developing a game. Perfect, exactly what we want right now. Debug, when you type dot, okay, that means you want to access or execute something inside that debug class. Okay, so debug is something provided by the Unity engine. There are lots of things you can use. If you type the dot, then you can access things inside that class. Okay, so in this situation, we want to access the method, so the letter M here, called log. Okay, perfect. If you look here, this is the signature of the method. Remember, we saw that in the previous video. We saw that we have a method called start. It has no return. Okay, the return type is void, and there are no parameters. In the case of the method called log, the log method has no return as well, and it has exactly one parameter called message, and that message is of type object. Okay, don't need to worry about the details about this object keyword right now. Just understand that you have to pass a message as a parameter here. Okay, so debug.log. And we want to pass that message as a parameter to the method call, to calling the log method. To do that, we open and close parentheses, okay, and we're going to type that hello world message here. So double quote, hello world, okay? We can even delete this line right now. But notice that when we typed all of this, we still see things in red, okay? Something is still wrong. You can even see that we have some red markings in here around the code, okay? And the reason this is happening is, whenever you finish writing an instruction, you need to add a semicolon like this, okay? It's not necessary when you're typing methods. You actually shouldn't use that when you're, opening and closing a scope. But for every other instruction, like calling the debug log method, writing this using instruction here, using the using keyword, you have to add a semicolon. It's like saying, hey, this instruction ends here. Let's go to the next one. Okay? So whenever you finish doing that, go to File and hit Save, or hit Command S or Control S. We're going to Unity. Once you go to Unity, you can see here in the bottom right, a little loading circle is going to execute. And after it vanishes, it means that the script has finished loading. And then what most of you are going to do right now is just hit play. Okay, it's like executing the code you just made. But wait a minute, what was supposed to happen? What I wanted to do here is, if you look at the console window, the message hello world should appear here, but it's nowhere. It's not in the game window, not in the scene window. The message is not working. Okay, so why exactly this happens? Remember, notice that we are writing code, we made a class, there is a class file, but Unity doesn't call these classes, they call these scripts. And we want to borrow a little logic from cinema and from theater. A script is like a piece of paper containing several instructions for you. Okay, it's like saying, hey, at this moment you should speak this paragraph. After that, you're going to look surprised, okay, or even scream for some reason, or jump, or feel happy, be filled with joy. It's going to be a set of things you have to say and do. And that's going to work with Unity. We wrote a script called player, but we need to give that script for the player for them to behave like we are writing here. Okay, right now, nothing happens. Okay, we just have the default behavior for this little guy here. But for him to read the player script, we need to give that script to the player. Okay, so how Unity does that? We have the third-person controller here. I'm going to just collapse these components just to make things easier for us to see. Okay, we collapse all of them. And I'm going to grab this player from the project window and drop it here. Okay, you can either do that, drop here with the third-person controller selected, or drop here as well. It's going to work the same way. So if you release that, you're going to see that you have a new component. Then you might be a little bit confused. Hey, is it a component or is it a script? It's kind of both. When you make a script, you attach it to a game object to have that script work as a component. Okay, this is a script component, the one you just created. So it's not a transform, it's not the camera component. This is not the light component, it's the player component, the one you created, the one where you can write custom behavior, like showing health, like showing ammunition, okay? And this time, when you press the play button, okay, you wait a few seconds for the scene to load, and you're going to see a message here, hello world. If you look at the console, the message is here. If you double click it, you can even be brought to the script that just showed that information message, okay? Notice that this message is just for showing some info, okay? It has this white icon. If there is a warning, it's going to be yellow, and if there is a problem, if there is an error, it's going to show in red. So for instance, if I were to go to Visual Studio and if I forgot to add that semicolon, if it was red like this and I saved and I went to Unity, we're going to have a problem here. It's going to say, hey, there is a problem in the file player.cs for C#, and it's going to be even more specific. In line 10, column 2, it's going to say there's an error of a certain code here, and it's essentially going to tell you what you have to do at some times. it's going to say semicolon expected. So another tip for you, many people, they get desperate when they see several errors in the script. They might be a little bit lost trying to find the solution, but most of the times the solution might be written here. Sometimes you just forgot to write a character or put some parentheses of closing and opening parentheses. And because we code so much, I mean, since we get so involved into the game we are making, it's easy for us to leave a few characters behind. I mean, we just forget to do a few things. Just look what the console has to say to you, and if it's not enough, you can just browse the internet. Training that curiosity, as I told you before, is really important, because you have to search the solutions by yourself. Okay? So it's going to save the error. We just double-click here, add a semicolon here, we save. Then we go back to Unity, wait for the compilation process to be done, and once it's complete, it's going to vanish. And you can clear the console and try it again. Okay, if you press play, it's just going to say hello world, and it's going to work, right? But notice the message is printing only once here in hello world. What if we took this line from the start method and put it in the update method? Okay, in the update method, we're going to type this just for testing. Debug.log, and between parentheses, we're going to add 2 double quotes, and we're going to type update. Okay, we finished this line with a semicolon, we save the script, we go to Unity, we wait for our script to be properly processed, and once that's complete, we're going to press play to see what's going to happen. This is going to be really quick, so we press play, we look here, and all we see is update, and we can see the update message is being printed over and over again. If you look here, and there's going to be a huge count of update method of informational messages like this. There are more than 1,000 messages being printed in our console while the game is being executed. This happens because, like we saw before, the update method is called on every frame. So whatever instruction you put there, you're going to see lots of updates. So where's the hello world message? It's in the beginning of the console, but since there are thousands of messages, you won't be able to see it. What you could do here to help you is click in the collapse button you see here. Hit collapse, and instead of printing several times the same message over and over again, the messages are going to be stacked. So instead of that, you have the message and how many times it happens one after the other. Okay, so over 4,000 messages here. All right, so that's just for testing to show you how you call a debug log message, how the start method behaves, how the update method behaves, and how you can make little errors from time to time. But if you have problems, if you have compilation problems or execution problems, don't worry. Okay, this is completely normal. This is part of the learning process and the development process in general. Okay, so I'm going to take that off here. Let's just leave the hello world message here, and in the next video we're going to learn a little bit more about what we can do to use scripts and give custom behavior to the player. So I see you soon. Even though we learned about methods and we can do a lot with these methods, we need to learn about a new concept, which is variables. So variables is probably one of the first things you learn about whenever you are whenever you're learning a new programming language. But since we had methods here, it was a better idea to just start talking about how methods work. But what are variables? Whenever you use a computer program, it's going to store things in its memory. So, for example, let's make a very quick example here. Okay, in Unity, we have this character, and this character is going to be stored somewhere in your computer, in your memory. So it knows the character is here, and it knows other characteristics like how the hair is going to look like, where are the glasses, or how many limbs it has, how many scripts it has. So many things are being stored in your computer, and you can store your very own information, the things you want to store. So for instance, if you have this character, you can save things like its name or age, or maybe how many bullets they have for shooting pistols, how many rockets they have for rocket launchers. So all of these things are variables. there's special places in computer memory that are going to store certain things, which could be strings or it could be numbers, it could be prefabs, for example, and you can give a friendly name for these things. So for example, we want to give a name for the player. The name of this variable could be player name. Okay, it's the variable we want to create right now. But for player name to exist, we need to give it a type. Okay, you can't just create variables at random. So if you have experience with JavaScript or with other languages, sometimes you just say, hey, this is a variable. I'm not going to determine the type of the variable. But in C# you have to determine the type. So it's a strongly typed language. You have to define if it's a string, if it's a number, if it's a Boolean value, whatever you can imagine. And I personally think that is good because that's, again, more organization. Your code is going to be tidier. It's just going to be better. Okay. The type of player name is string. Okay. It's a string of characters. It's essentially text. All right. String, player name, and a semicolon. Okay. This is called the instantiation of a variable. You are telling your code that a variable with the name player name exists, and the type of that variable is string. Okay, it only contains text. If you try to store a number there, it's not going to work. It needs to be something that is enclosed between double quotes. So we just instantiated this variable, but that's not enough. You still want to store information there, so you have to save something there. So you want to initialize this variable. You want to start by adding a value to it. So I'm going to type equal, the equal sign here. Then we add two double quotes, and we're going to name whatever name. We want to give whatever name we want. And I'm going to start with Bob. Okay, something really simple. So we instantiated a variable. Okay, we declared a variable. Actually, we're determining that there's a variable called player name with the type string, and we are starting it, we are initializing it with the name Bob. Okay, so string, player name, Bob. All right, and instead of start here, instead of this string that we typed here, hello world, we're going to say hello, like this. Okay, so hello, an empty space. And we continue these strings. We're going to type plus, and I'm going to type player name, like this. Okay, so player name is Bob, and we're going to print hello plus player name. And I'm going to explain a few things for you soon. If we save this, we go to Unity. We wait for the script to be complete here. Once that's done, I'm going to press play. Right, just a few more seconds. And once we press play, in the console we see hello Bob. Okay, so we created our variable, we added a name for it. Okay, we instantiated the variable, we initialized it with a string, and we created the string hello Bob, even though hello Bob is not specifically written in here. You could change that to another name if you want. Okay, and it's going to print that other name. So what happened here? Even though we are using the plus sign, operators, okay, as you see here, the name string.operator, operators might change for different object types. So for instance, if you have two strings, the plus sign is going to append these strings. It's not going to be a number sum. Okay, it's not going to be an arithmetical operation. This is an append operation. You get one string, hello, and put it in the side of the other, which is Bob. So the result of this is hello Bob, right? If it was an addition of numbers, if you put 2 plus 3, of course that would be 5, okay, because the numbers would be added one to the other, right? And this equal sign here, we are not making an equation like in mathematics. It's not like saying, hey, 5x equals 10, find x, for example. This is different. This is an assignment operator. We're putting the value Bob inside the variable called player name. Okay, so we're not comparing things, we are assigning things. We get a value and we store here. Okay, so hello and the player name. All right. So another thing we want to use is create another variable, a variable used for storing numbers. Okay, we could store, for example, the player's age and print that as well. Okay, so here I'm going to type age. All right, we need to determine a type for that age, which I'm going to type int. Okay, so int means integer, is a number with no decimal places. So 1, 2, 3, only whole numbers, never 2.5, for example. Int age is going to be, let's say, 20, for example, in a semicolon. And then we could print another message here called debug.log, and then between double quotes, your age is plus age. Okay, the same thing as before. So if we save this, go to Unity, we wait for the code to compile. Let's also stop the execution of the current session in the game and press play again. The console is going to say, hello Bob, and your age is 20. So that's quite interesting. Before I told you here, this is going to append two strings. In the case where we have a string and a number, C# is going to automatically convert this to a string and make it all string. Okay, but some things might not work. If you have the number first and then the string, there might be some problems depending on the programming language you're going to use. But again, you're basically adding things. All right. But let's say we want to know the birth date of the player or the birth year. How exactly would we do this? Instead of your age is, I'm going to type you were born at, okay, and then instead of age, I want to type 2018 minus age. Okay, let's see what's going to happen here. Notice that everything is red because this is not being correctly converted. This is going to return a string, and we can't use the minus operation for the age. We want this to be resolved first. We want this to be evaluated first before calling this plus sign. So I'm going to put this between parentheses, 2018 minus age. Internally, what's going to happen? C# is going to do this calculation, 2018 minus 20, and only after that it's going to add these two elements. So the parentheses, they have priority in the execution. Okay, so instead of doing things in order, C# is going to do that first because this is inside parentheses, and then it's going to do that. You might remember that from mathematics when doing add and subtract operations and multiplication and division. Okay, if you save that and you go to Unity, we stop the current game session and we start a new one. Let's look at the console. And it's going to say, hello Bob, you were born at 1998. Okay, so essentially that's what's going to happen. So what I'm showing you is you can have different types for variables like player name and age, and you can do different types of operations. You can append strings and you can work with these numbers. Okay, and one interesting thing here is age is not a number. Age is a variable, so this is a reference to this variable here. What C# does internally in your computer or in your mobile phone is going to retrieve the name that's stored in this variable and is going to internally do this. Okay, so it's going to be 2018 minus 20, and then it's going to operate just like you see here. Do the subtraction and then append the string. Okay, very important for you to understand these things about variables, about how we can make these variables work with each other. Okay, and essentially that's how it's going to happen. So we're going to do something interesting in the next video about access modifiers for the variables. So I see you in the next video. Okay, so we have two different variables. We have player name and we have age. There's something that's bothering me a little bit, and it might bother you as well. If I were to change this age to 22, for example, and I saved this script and went for Unity, I can't press play straight away. Okay, it's going to wait a little bit because the code is still being processed. You still have some loading time before you press play again, and then you see the results of whatever you did here. So you're born at 1996. There's something that we can do in Unity to expose variables to the Unity editor, which is very useful. Okay, again, we need to use the full potential of the tools we have available for us. We need to learn these little tips, these little tricks to make things easier to work with. So if you go to your script here and you type public, just like that, public string player name and public int age. If you go to Unity and wait one more time for the code to be compiled, you're going to see here in the player script you have two new fields. So you created your very first fields in Unity, player name and age. And now here's the good part. Whatever you put here, it's going to override what you put here in the variable declaration. Okay, whenever you initialize it here. If you change it in other method, of course, it's going to be overridden. But here in Unity, when you start, whatever is written here is going to be set. So if I change his name from Bob to Ethan, for example, which is the name in Unity, and I change the age to 25, for example, if I press play, in the console you're going to see these two messages. Hello Ethan, you were born at 1993. If I were to change that, I can just stop the simulation, change the name back to Bob, change the age to 26 or 27, for example, press play again, and it's going to say, hello Bob, you were born at 1991. So we have these two being printed here. We didn't have to touch the code. Even though we are learning how to script, we are learning how to make our lives easier. We don't have to go through this compilation process at all times. Just expose variables, and it's going to work well. There are better ways to work with these things into making them exposed in Unity, but it's not necessary for this tutorial. We are learning, we want to do things quick, we want results, and we want to do as quickly as possible. Okay, so what we did here, we typed, we had an access modifier, okay, called public. It's just like the one you see in the class. When we type this as public, other classes can access these two variables we have in the player, okay? You have to know exactly what you're doing because using access modifiers might be dangerous. So for instance, we don't want a bullet to be able to change the player's name. It doesn't make any sense at all, okay? But I don't know, there might be other examples, other better examples, but you have to make sure you're going to protect your code, okay, from doing this little problems. So they're set as public right now, but just need to be a little bit careful on whatever we use these values here, okay? But again, it's going to be fine for this course. We have player name, we have age, and if you want a variable not to be accessed, okay, not to be fully visible like this, you could use the private access modifier or not type it at all. Private is going to be used as default. So for example, I'm going to type here private. Let's add a float for floating point numbers, health, and I'm going to say that health is going to be 100.0f. Okay. Whenever you add a floating point number, you can have decimal places, and to work with floating point numbers, add an f in the end. Okay. Let's use just 100f. If you save that and go to Unity, since you changed your script, of course, it's going to compile again, but you're going to see health is not going to be visible. Okay, you even see a warning here because we created the health and its value is not even being used. Okay, C# does that to allow you to verify if you're, not declaring things that won't be used and just going to waste space. But we could quickly use it here and say debug.log and then health colon space and outside of the double quotes plus health. Okay, this is the string, but this is the variable health. All right, save that, go to Unity, wait for compilation to be done. We're going to press play, and this time no warnings, and we're going to see the health points of the player. Health 100. Okay, so perfect. Now we learned how to use these access modifiers. Okay, we have the public one for player name and age, so we can expose that in Unity and make our lives easier, but we also have a private one for showing the health. Okay, so we learned how to work with text and how to work with numbers, with integers and floats. Now, what about the Boolean variables? What are Booleans? We're going to learn about this in the next video. Last video I told you about Boolean variables. I mean, what are them? Well, how can we use these Boolean variables into our games? Boolean variables are essentially values that can be either true or false. It's kind of a yes or no. For example, the player might have an invincible state, okay, where nothing is going to damage them or reduce the health. So to save that information, if the player is invisible or not, we could make a Boolean variable called isInvisible. Okay, so that's essentially it, true or false. I'm going to add another variable here. I'm going to type public and then bool for a Boolean variable. And let's type in here a power up, okay, like this, right? That's all we're going to write for now. Public bool power up. We're going to save this. We go to Unity. We wait for the code to compile to be processed. And if you look at the player component, you're going to see power up and a checkbox. So Unity is going to interpret that Boolean variable that we set as public, and it's going to understand, hey, since power-up can only be true or false, I'm just going to add a checkbox here. If you click on the checkbox, it's going to be true. If you unclick the checkbox, okay, so if you click again for the tick to disappear, it's going to be false, something really, really quick. And in Visual Studio, I'm going to say debug.log, and we're going to type, let's type a question here. Does the player have a power-up? Question mark space, and then outside of the double quotes we're going to append power up. A very quick test, okay? And remember to add a semicolon in the end. Take your time to write this message. Okay? So, in Unity, we wait for the code to be processed. After that is complete, we're going to press the play button here. Let's wait for a little bit, and it's going to say your name, your when you were born, your health, and it's going to say, does the player have a power-up? And it's going to say false. But if I stop the game, if I click on the power-up checkbox again and I press play, it's going to say, does the player have a power-up? True. So that's essentially it, true or false. That's the first time. If that's the first time you're working with Boolean variables, you might be thinking, okay, why is it useful to use things like true or false? Okay, if you look at the string, if you look at the text, true or false, it's essentially useless if you think it as a text. But if you think about its value, saying if something is true or false, if it's yes or no, that's, I mean, everything you see when you're playing a game is either true or false. To make a character move, you're going to check if you're pressing the right key. And pressing the right key is essentially asking the computer, is the player asking the right key? That's true. If the player pressing the right key, that could be false if the player is not pressing. So everything in games is true or false. I mean, it's used everywhere. Does the player have a power-up? Was the player hit by a bullet? Is the player alive? Are any players connected to this room? I mean, everything you can imagine is either true or false. And what you could do here, to make a very simple test, is instead of writing this line, we're going to delete it right now. And we're going to use a very important instruction in game development. We're going to type if, okay? So that's a conditional statement. If is essentially you're going to ask if something if some value is happening. Okay, so if, for example, power up, then do this. That's how you write all of this. Okay, let's just change power up to has power up. Okay, has power up. That's going to be better for this situation. Okay, so we're going to have a variable called has power up, and then if has power up is true, then do something. So I'm going to type here debug.log power up like this. Okay, so we're going to save this script and we're going to see what's going to happen. I'm going to Unity, wait for the code to compile. The power up text here is going to change to has power up and it's unmarked. Okay, we're going to clear the console. I'm going to press play. And if you look here, this time we only have the name, the year, and the health of the player. We don't have any other messages being displayed because has power up is unchecked. Since it's unchecked, the variable has power up is going to be false. Since it's false, okay, since this is going to evaluate to false, nothing between parentheses is going to be executed because that needs to be true. whatever is between parentheses here in this if checkbox needs to be evaluated as true, so its instructions are going to be executed. Okay, so if you go to Unity, you select the has power up checkbox and you press play. Okay, just a few more seconds, you're going to see power up. Alright? But you might be asking yourself, hey, what if I want to tell the player they have to find a power up so they're going to be stronger and they're going to beat their enemies? To do that, you can use the else instruction. Okay, so you type else, open and close curly braces, and do whatever you want here. For instance, you can type debug.log search for a power up. This is a very important, a very strong block. You can do a lot with this. Okay, if something, then do this. However, if that something is false, do that. Okay, let's save this script, go to Unity, we wait for the code to be compiled, and now if I press the play button, we're going to see the second message, which belongs to the else block. So it's going to say search for a power up. If I mark the checkbox and I hit play, it's going to say has power up. Notice how I'm getting these basic concepts, these very simple things, and I'm repeating them over and over again. I'm doing that because it's really important for you to understand all of them in order to move forward and make this game work. Really need to make sure the basics are very well understood. Okay, so power up and search for a power up, and that's basically how you work with Boolean variables, and you use the if-else blocks. Another thing, I used before the word evaluate. So evaluating is basically getting whatever is between parentheses and getting its final result. In the end, has power up is either true or false, but you could do other operations here. Okay, 2 is a number. It doesn't make sense. Whatever is here needs to be a Boolean variable. Okay, notice that if I hover the mouse into this red line, it's going to say cannot implicitly convert type int to bool, because whatever we have here needs to be a Boolean variable. So numbers won't work. Okay, if I type a string here, for example, it's also not going to work because we need to have a Boolean variable. So what if I want to ask, hey, what if the age of the player is 22? Okay, we're going to notice that we're learning about things and we're mixing everything here. What if the player was born in 1991, for example? How do I ask this here? We're going to type if 2018 minus age equals to 1991. Okay, so what am I doing here? Why does this work? Okay, because we're using numbers here, we're using an equal sign. Why is this Boolean? Because this operator here, different from a single equal sign, this is going to compare if two things are equal. Okay, so if the left side equals the right side, okay, and this is something that returns either true or false, which is, in the end, it's what I want. Okay, so here in the first message I'm going to say, hey, you were born in 1991, else you were born in another year. Okay, so we're going to save this script and go to Unity, wait for the compilation to be finished. Notice that we're no longer going to use this has power up field, and if you press play, it's going to say, wait a few seconds, you were born in 1991. Perfect, that's the message we wanted to print. But if I went here and I changed the age to 14, for example, and I hit play, wait a few more seconds, and it's going to say you were born in another year. Notice that even though we're not explicitly using Boolean variables here, this still evaluates as a Boolean variable. And this is also really, really important. We use these kinds of things to see if the player has enough ammunition, or if the player has a certain power-up, if they have a certain weapon. We need to use Boolean variables to do that kind of thing. Okay, if and else, if and else. We always do that in games. If you cross a certain border, if you jump over a certain enemy, if you hit a rocket in a flammable, box, for example, and it's going to explode. Everything we do in games, it's if and else. So really important for you to get this concept. All right? So let's move forward to the next video where we're going to learn a new useful concept. Alright, so now that we learned about Boolean values in the if-else structure, there are two other things we need to learn that are very, very useful. We're going to learn about loops, the for loop and the while loop. So to do that, let's clean things up a little bit here. I'm going to take off these variables and let's do a clean start with the start method. Okay? So I want to print several numbers. So let's, for instance, type int year equals to 1991, for example. Right? And I want to print all the years up to 2020. Okay? So how can we do this? Let's use the while structure. Okay, so how while works? While something is true, do this. Okay, that's essentially how the while structure happens. If it's true, it's going to keep executing until whatever is here becomes false. What I want to do here is, while year is lesser or equal to 2020, do this. Okay, this operator is going to return a Boolean value because it's going to compare if the left side of this statement is lesser or equal than 2020. Okay, so we're going to type here debug.log year like this. Okay, while year is lesser than 2020, print the year we are currently at. Well, there's one important thing here. If you were to go to Unity and you press play, you're going to add in something called an infinite loop. Year is storing 1991, and we're doing nothing to change that. Okay, year is not changing. It's not increasing or decreasing or whatever you can imagine. So it's going to print 2020 forever, and essentially what's going to happen is your game is going to stop executing. Okay, it's going to crash because nothing else is going to happen. It's just going to stop. So what we have to do here is change the year every time we do something, every time we enter this loop. So what I want to do here is to increase year by 1. Okay, to do that, you can type year plus equal 1. This is the same thing as typing year is going to be whatever is being stored in year plus 1. Okay, remember, different from this equal sign is not going to be a comparison. It's not going to return a Boolean variable. You're doing an assignment, and you're saying, hey, I want to store this inside the variable year. And what is this? 1991 plus 1. Okay, so it's going to be 1992. In the next iteration, it's going to print 1992 and then turn year into 1993, 1994, 1995, all the way up to 2020. Okay, so again, this can be, you can write that in a short way by typing year plus equal 1, or even shorter, year plus plus. This is more common here. Okay, so we're going to save that. Let's go to Unity, wait for the compilation to be done. All the fields are going to disappear for now for this example, and that is fine. We're just studying how programming works. We're going to press the play button at this moment, and in the console you're going to see lots of messages. So 1991, 2, 3, 4, all the way down to 2020. Okay, so that's essentially what you have to learn about a while loop. It's going to execute whatever's here while this is true. Okay, just be careful with infinite loops. Make sure this is going to become false at some point, right? But there's another way to type this. Okay, we don't even need to declare the variable like this. If you delete that, you can now make a for structure. Okay, and I'm going to start by typing this. Okay, let's add some spaces. So we have for, we have 2 semicolons between parentheses, and we open and close the curly braces. Again, no need to be scared here. We're just going to show you things step by step. So how does the for statement work? We do this, and then we're going to have a set of initializers. Okay, if you hover the mouse here, you can even see that. For initializers, expression, iterators, and then do something. Okay, so here we can initialize things like typing for int year equals to 1991. Just like we did before. Okay, here we want to add a condition for this loop to continue executing. So while, you can literally read that, while year is lesser or equal than 2020, or just 2000 to make things quick, while this is true, something is going to happen. Okay, your set of instructions are going to be executing, and in the end you're going to do year plus plus. So the for statement, in some manner, it's kind of a huge Swiss knife for loops. Okay, you initialize things, you check for conditions, and then you do the iteration. Okay, you do that kind of step you execute in the end of the for loop. So we do that entire instruction to type debug.log year. Okay, so year starts as 1991. While it's smaller or equal to 2000, we're going to print the year, and in the end we increase whatever is stored in the year variable. So if you save this and go to Unity, and you wait for the code to compile, just a few more seconds, I'm going to clear the console. We're going to hit the play button, and if you look at the console, it's going to print 1991 all the way up to 2000. Okay? Essentially, that's what you have to know about the for loop. And sometimes you might want to for instance, spawn 3 enemies, for instance. How do you do this? This is another important thing to learn about for loops. If you want something to be executed 3 times, you can just type for, then int I equals to 0, while I is lesser than 3, and in the end you type I++, and here you can just type debug.log, and let's just say hello, for example, or better than this, spawn enemy, for instance. Okay, so we start with a variable called I. The condition is it has to be lesser than 3, and in the end we increase it by 1. So what happens is I starts at 0. Is 0 lesser than 3? Yes. Spawn enemy, change I to 1. Okay, so we spawned enemy once. Then I is 1. Is 1 lesser than 3? Yes. Spawn enemy, increase I. I is 2. Is 2 lesser than 3? Yes. Spawn enemy, increase I one more time. Now I is 3. Is 3 lesser than 3? No. Then exit the loop. That's what's going to happen here. Okay, so I is going to be 0, executes, 1, executes, 2, executes, 3, don't execute. That happened for 3 times. Okay, if we save this, go to Unity, let's stop the simulation here and wait for the compilation to be complete. After that is done, we're going to hit the play button, and the console is going to show us spawn enemy 3 different times. Okay, you can even disable collapse here to see more explicitly the 3 messages spawn enemy. Okay, and this is going to be really useful for spawning enemies, for shooting multiple bullets. Okay, lots of different situations this can be used. Okay, so right now let's just clear the start method again. We're going to start from where we were before, everything before we typed our first lines. Just going to save. Let's go to Unity and have a clean state. Okay, remember here you're learning over the shoulder with specialists in Unity with game development and programming. So that's how we're going to learn. We're not going to use any boring slides, any PowerPoint presentations. We're just going to see things exactly as they look like in Unity. And you can do your own exercises in Unity as well. So I highly advise you to play a little bit with strings, ints, and booleans. Try a few loops. Try an infinite loop. And see what's going to happen with Unity. And just a quick tip, save whatever you did before so you don't lose anything when Unity crashes. And these tools are going to be everything. They're going to be, they're going to make the entire difference into making a good game and giving you the entire freedom to do whatever you want when you make your game. Okay, so at this point, let's save the scene. Let's also go to File and hit Save Project, and we're going to move on to the next lessons.